Hi all, welcome to the lecture series on Aerospace Propulsion. I am Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. Today, the topic which we are going to discuss is geosynchronous and geostationary orbits. Let us go to the overview of today's presentation. We are going to discuss about geosynchronous orbit and geostationary orbit, and we are going to discuss the conditions for a geosynchronous orbit and conditions for the geostationary orbit, and what are the differences between geosynchronous and geostationary orbit and applications of geosynchronous and geostationary orbit. Let us go to the first topic, that is geosynchronous orbit. So what is geosynchronous orbit? If a body is in a circular orbit and angular velocity equal to that of Earth and it rotates in the same direction as the Earth, then the movement will be synchronous with the rotation of the Earth. So if I take here, this is an orbit, Earth rotating about its axis with some angular velocity, and this object is also moving with some angular velocity omega. Okay, so this angular velocity of this object is omega and the Earth angular velocity also omega. If both are equal, then this body is synchronous with the Earth. So that's why this particular orbit is called geosynchronous orbit. What do we call this? Geosynchronous orbit. So the object in the orbit is synchronous with the angular velocity of the Earth. That's why that particular orbit is called geosynchronous orbit. Okay, generally these geosynchronous orbits will also take the same time, that is, the time period of geosynchronous orbit is 1 day, approximately 1 day. Here you can see the diagrams. This is the North Pole and this is the South Pole. Here also it is North Pole and South Pole. And you can see this orbit is moving through the polar. Okay, this orbit is moving through the North Pole and South Pole, making perpendicular to the equatorial plane. If you consider this is the equatorial plane, it is making almost 90 degrees. And if I take here, if I consider this is the equatorial plane and here it is making some angle theta. So this geosynchronous orbit is making some angle theta and the angular velocity maintained is equal to Earth angular velocity and the orbital period is equal to the Earth rotation time, that is 1 day. So that particular orbit is called geosynchronous orbit. So how to calculate the angular velocity need to be maintained in a geosynchronous orbit, and what is the altitude of the geosynchronous orbit? Let us discuss now. So if you go to the Earth will complete one rotation, right? Earth will complete one rotation in one sidereal day. Generally, we think Earth takes 24 hours to complete one rotation, but actually the time taken for the Earth to complete 360 degrees rotation, 360 degrees rotation is called sidereal day. Okay, sidereal day needs to be considered to determine the angular velocity of the rotation of Earth about its axis. So we have to consider the time taken for the Earth to complete 360 degrees rotation, that is sidereal day. Actually, the sidereal day is not exactly 24 hours. It is some less than 24 hours. So during the period of rotation of Earth on its axis, it moves a short distance along its orbit, approximately 1 degree. Suppose if I consider this is the Sun, okay, and this is the Earth. Okay, this is Sun and this is Earth. Earth is rotating around its own axis, and at the same time Earth also rotates around the Sun. So while it is making around its own axis, it also makes some distance in 24 hours. It also makes some distance in the Sun's orbit. So that is by around 1 degree. Because of this distance covered by the Earth will take some around 4 minutes less to complete 360 degree rotation. So the sidereal day is shorter than the solar day, which is about 4 minutes. So the actual duration of the sidereal day is not 24 hours, it is 23 hours 56 minutes 41 seconds. How much? 23 hours. Sidereal day is 23 hours 56 minutes 4.1 seconds. So while calculating the earth angular velocity, what we do? Omega is equal to angle covered by the distance, that is 2 pi radians, divided by the time taken for the earth to complete 360-degree rotation, that is not actually 24 hours. We have to consider this here, sidereal day, 23 hours 56 minutes 4.1 seconds. This will give you the exact angular velocity of the earth. So if you calculate that exact angular velocity of the earth by substituting this 2 pi and the time, this 23 hours 56 minutes 4.1 seconds, if you convert this total into seconds, then it will be 86,164.1 seconds. So substitute this 86,164.1 seconds in this angular velocity, then you will get the angular velocity of the earth is how much? 7.293 into 10 to the power of 5 radians per second. The angular velocity of earth is 7.293 into 10 to the power of minus 5 radians per second. Right? So this is geosynchronous orbit angular velocity. So we have to maintain an angular velocity of this much so that the object will be synchronous to the earth rotation. Right? It is okay. So we found the angular velocity of the object to be maintained in the geosynchronous orbit. Okay. Then what is the orbital velocity to be maintained so that object stays in the geosynchronous orbit? Now we are going to find the orbital velocity also, and also we have to find what is the exact altitude so that it is synchronous to the earth rotation. That also we are going to find now. So angular velocity of the orbit is seen to decrease with increase in the radius of the orbit. That already we know. So coming to the next, a geosynchronous orbit is a specific type of next topic is geostationary orbit. Geostationary orbit. So geostationary orbit is almost similar to the geosynchronous orbit. A small difference will be there. So if you see here, a geostationary orbit is a specific type of geosynchronous orbit, and that is nothing but it lies in the equatorial plane. It lies in the equatorial plane. Geosynchronous will have some inclination theta with respect to equatorial plane, but geostationary orbit lies in the equatorial plane. It is nothing but a geosynchronous orbit which lies in the equatorial plane is nothing but called as a geostationary orbit. So if you take here, a satellite in this orbit has not only 24 hours time period but also rotates in the same as earth direction, and it lies in the earth equatorial. So the altitude is 35,782, and most of the places it will be considered 35,786 kilometers. Okay. Next, we have to calculate the radius of the geosynchronous orbit. Radius of the geosynchronous orbit. So we know the formula V is equal to R omega. So this is omega. Omega we know, right? We know the formula of omega, that is under root G me by R cube, and this R is what is not RG is the radius of the geosynchronous orbit, and we calculated the angular velocity of the earth. So if you substitute omega E here, then we will get the value of RG here. So finally RG cube is equal to capital G me by omega E square, and if you substitute this omega E here, and you will get radius of the geosynchronous orbit is 42,160 kilometers. 42,160 kilometers. This is radius, not the altitude of the geosynchronous orbit. This is the radius of the geosynchronous orbit. That means from the center, earth center to the orbit. 42,160 kilometer. 42,160 kilometer. Suppose if I want to calculate the height of the geosynchronous orbit, so what should I do? This is radius RG, right? Radius of geosynchronous. Then if I minus the radius of the earth, then I will get the height of the geosynchronous orbit. Hg is equal to radius minus radius of the earth. So if I substitute that, and the radius of the earth is how much? 6378 kilometer. And if I substitute that 42,160 minus 6378, then I got around 35,786 kilometers. Around 35,786 kilometer above the Earth's surface. So the altitude of the geosynchronous orbit is 35,782 kilometers approximately. Next, coming to the applications of geosynchronous and geostationary orbits. Coming to the applications of geosynchronous and geostationary orbit. So before that, we need to discuss some more points about the geosynchronous and geostationary orbit, right? And what are the differences, right? What are the differences between geostationary and geosynchronous orbit, right? We have to discuss that. So if you consider the geosynchronous orbit, the time taken, if any particular day, suppose at today at 9 p.m. and our satellite is at an angle of 30 degrees to me, towards my left, okay, 30 degrees, making 30 degrees inclination towards the east, okay, towards the east at 9 p.m. Next day also, if I observe at 9 p.m., the satellite remains in the same place in the geosynchronous orbit. So in the geosynchronous orbit, the object repeats its position in a particular every day at particular time. Coming to the geostationary orbit, the position of the object is stationary with respect to the any point on the Earth. Why? Because the object lies in the equatorial plane and it is moving with the same angular velocity. So the position of the object with respect to any point in the geostationary orbit is fixed. Whatever the time you take at 1 p.m., 2 p.m., 3 p.m. or 11 a.m., whatever the time you take, the position of the object in the geostationary orbit does not change. Whatever the time you observe, it will stay at the same position from a particular point on the Earth. So this is the difference between the object. This is the difference between geosynchronous and geostationary orbit. Okay. Coming to the applications. So we generally geosynchronous orbit, we use communication satellite. We send communication satellites, scientific and observation satellites, military applications, navigation satellites. For navigation satellites, we can use geosynchronous orbits. Okay, what happens is geosynchronous orbit will repeats its position at a particular time on the Earth. Coming to the geostationary orbit, so we can use geostationary orbits for TV broadcasting, weather monitoring, broadcasting and cable services, Earth observation, and military communications. So these are the applications for geosynchronous and geostationary orbits. So coming to the summary of today's topic, we gone through the geosynchronous orbit, we have gone through the geostationary orbit, the difference between geosynchronous and geostationary orbit, and the applications of geosynchronous and geostationary orbit. Thank you.